solubility curves, and we're going to look at examples to help us understand how to use or read the graph. So on the first question, it's asking which compound is least soluble at 20 degrees Celsius and then at 80 degrees Celsius. A couple of things to remember: if you look at the key that's on this graph, it shows you that solids are going to be solid lines and gases are going to be the dotted lines. And you're going to notice that the solubility is going to increase. In other words, it's going to be more soluble in water when there's a higher temperature. The temperature being the x-axis and the solubility being the y. For gases, it's the opposite. As the temperature increases, then that means that solubility is going to drop. Think of having a soda out on a warm day. It's going to get flat because the gas isn't going to want to be soluble inside the solution. So let's look at the first one. It says which compound is least soluble at 20 degrees Celsius. So we look at the temperature. Here's 20. And what you want to do is you want to find which one of these lines is lower on this spectrum. Which one has less amount being dissolved into 100 milliliters of water. So 20, the first line it hits is going to be this one right here. So this one belongs to potassium chlorate. So therefore, in this particular question, potassium chlorate is going to be the one that has the least solubility. For 80 degrees Celsius, we do the same exact thing. We look at the temperature. We find out that it's a gas because it's a dotted line. And this one is sulfur dioxide gas. And that one is the least soluble at 80 degrees Celsius. To be specific, it's going to be about 5 grams per 100 milliliters of water. Looking at the next question, which substance is the most soluble? Now the opposite, at 10 degrees Celsius. So rather than looking at the one that has the least solubility, you're going to look at the numbers higher up. So at 10 degrees Celsius, you're going to notice that the most soluble, or the one that it hits at the very end, is potassium iodide. It's about 135 grams that you can dissolve per 100 milliliters of water. So that's quite a bit. At 50 degrees Celsius, okay, you follow it all the way up to the top, and the line it hits is a one for sodium nitrate, and it's approximately halfway between 110 and 120. So we could call it about 115, maybe a little bit lower, 114, but that's going to be the one that's the most soluble there. At 90 degrees Celsius, okay, you keep following it. I know it touches this line. You can make the assumption that this might follow through, and we could say that sodium nitrate will be the most soluble. But if you want it to be exact and go off of whatever the graph is telling you, then we can say that ammonium chloride is the most soluble, that we could see for sure. Okay, so here's a couple of things that you're going to want to write in your notes. And you can go ahead and put them in the next available page in your ISN. But when we call something saturated on a solubility curve, it's because the plotted point is going to be exactly on the curve, or in other words, on the line. If we say that something is unsaturated, that means at whatever point we plot it is going to be under the curve. So it's going to be right below it. And when we say something is supersaturated, that means that the plotted point is going to be above that curve that we're looking at specifically. So a couple of examples. So it says we have 50 grams of potassium nitrate at 50 degrees Celsius. So here's 50 degrees Celsius, and then we need to look at the 50 grams and plot that point. So it is right here. Okay, now we're going to take a look at which compound they're referring to. It's potassium nitrate, so we're going to look at its curve, which is right here. So if you notice, in comparison to the curve, this plotted point is under the curve. Because it's under the curve, we're going to say that it is unsaturated. So here we would write that it would be unsaturated. If we look at the next one, it's asking us if what it falls under, saturated, unsaturated, or supersaturated for sodium nitrate. We plot the point, so it's 100 grams at 80 degrees Celsius. So here's our temperature, 80 degrees Celsius, and then we have to find 100 grams. So we go up, 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 and it is right there. So there's our plotted point. And then we look at which compound we're referring to. This one is sodium nitrate. So we look at it right here. So this is our plotted point, and right here is our curve. So we have to decide which one of these is it. Because it's under the curve, it's going to be considered unsaturated, under the curve. So our answer would be unsaturated. Another example might be looking at when one of these reaches exact saturation. So let's take a look at potassium nitrate. So let's just say that I'm asking at what point is potassium nitrate saturated when it reaches 50 degrees Celsius, or how much is soluble? So we look at 50 degrees, and at 50 degrees you can dissolve approximately 85 grams. So that's when it's at saturation. If we take a look at another one, we could say another temperature, or we could look at the amount and say, let's say for potassium chlorate, take a look at 20 grams of solume. And I can ask you, at what temperature will 20 grams reach saturation for potassium chlorate? So you follow the line until you actually meet the curve for potassium chlorate, which is about right here. So you could say that I can dissolve 20 grams of it